we've been starting this whole idea with the geometry of the Earth and looking at, I guess, distances and latitudes and longitudes. And we're going to take that to another type of question now. And the first thing you want to be aware of is this definition here. A great circle is, imagine like a slice through the sphere. Okay, and it has to go through the center of the sphere. So if you got this orange here, right, you can make any cut that goes through the center. Okay, and so if you think about it, if we're cutting it down, right, if I cut it down anyway, I'm always going to be going through. Yeah, I don't want to cut myself. I'm always going to be going through the center. What about if I'm going across?
You're still going to the center.
Yeah. What about here?
Still going to the center.
What about the center of the sphere then? The center of the sphere. So I need to cut through the center of the sphere. That's called a great circle. Okay. If I'm slicing through it, I want to cut through the center of the whole sphere. If you think about it. So any cut through here will give me the whole sphere. Right? But what about if I made a cut at the top, close to the top here? Am I going through the center of the sphere?
No.
I'm not.
You're going straight.
Exactly. So I have to make a cut either straight down the middle, right? Or if I'm cutting across, it has to go through, if you imagine this on the globe, what line would that be?
Equator.
Good, okay? So, I refer to the great circles either as the equator or any longitude. Because the longitude are the lines that go down, right? But the equator is the one that goes across. That's something really important to know. And any small circle, that's any other slice we can make. So if I just did a little chop here, that would just be a small circle, okay? Cool. What are the kinds of questions they want us to answer? Well, the questions will generally involve 2 points, A and B. And they'll ask us to find distances, or they'll ask us to find something called the angular distance. And what's the angular distance? Well, it's simply the angle between the 2 points from the center of the Earth, called O. Okay, so the angle AOB, whenever they're talking about the angular distance, right, that's what they're referring to. Okay, keep that in mind for the next few questions. Cool. Tom, can you read out the first one for me?
On the sheet.
Yeah, example 1.
In the diagram on the right,
Yep.
A and B on the Earth's surface have an angular distance of 63 degrees. Calculate the great circle distance between A and B, correct the nearest kilometre.
Okay, the first things first, we want to be using this formula here. We learned that in a few chapters ago. It was the arc length. Okay, and Joe asked a really interesting question. We know we need theta, and we know we need the radius. What would be the radius in this case? Do we know it?
No.
It's R.
Right.
We
We don't know the value. But on our formula sheet, something that I told you to be aware of is that there's a lot of information there that you might not know that's actually there. And the radius of the Earth is actually a piece of information on your formula sheet. Can someone find that?
Yeah, 6,400.
6,400. Good.
That's it. It's only 6,400 kilometres.
Radius.
So the diameter would be double that, right? You got a
That
question?
doesn't seem like that much.
Why don't you try measure it for me, Tom, and then you can come back. You want to verify that theory. What's up? So the radius, right? It's not given to you on the question, but on your formula sheet, this is actually a fact that is provided. The radius of the Earth is 6,400 km, and that's on your formula sheet. Make sure you know that that's there. 63 degrees was the angle given to you in the question, okay? And then all you have to do now is substitute it in, because what's the question asking? It's asking you to find the distance from A to B. So the distance from A to B would just be that arc length, okay? So this is going to be L.
Is that an L?
Yep.
Okay.
So you get 7037.167. Remember, to the nearest kilometer, we'll round down to 7037, okay? Any questions on that?
Okay, so someone else started going to find out what we need to try and do.
Yeah. You'd also have to dig through the Earth, which is very tricky. So.
Yeah, well, you got a spoon.
You physically can't because you die.
Okay, Jordan, can you read the next question for me? Example 2. Example 2, yeah. Thanks, Jordan.
Beijing, China, and Perth, Australia have coordinates 40 degrees north, 116 degrees east, and 32 degrees south and 116 degrees east, respectively. What great circle joins Beijing and Perth?
Cool, stop there, thanks. Okay, so first things first, when you're answering these questions, I've left a little blank space for you. Here's what I want you to put in there. Anytime you're starting one of these questions, even the, what was that, Chloe? Draw a picture, right, okay. So,
Is L looks like a
Okay, so we're not going to draw a 3D representation because we don't actually need to. So can I ask you just to draw a 2D representation of this? What would that look like? Well, you've got 116 degrees as your longitude.
So let's draw a square.
Yeah, we can draw a square.
Wait, what? Oh.
So you don't actually need a 3D representation to achieve the answer to this question. We just want to draw a 2D representation. We've got 40 degrees north and we've got 32 degrees south. In the middle is there. Just do a dotted line to represent the equator. Okay, that's 0 degrees. And on the top, we've got Beijing, so I'll put B. And the bottom, we've got Perth, so I'll put P. And notice that the longitude is the same. They're both 116 degrees east. That's going to be really important. For question A, they're asking us what great circle joins Beijing and Perth. And we want to come back to how we actually refer to these great circles. They either have to be the equator, or or there has to be some longitude, and exactly as Joe said, 116 degrees east.
I'd rather say that.
Yeah. Cool. Okay, the next question. What is the angular distance between these two cities? Chloe, can you remind me what is the angular distance again? What are we talking about there?
I'm not sure to be honest.
Talking about the angle from the center of the earth.
Good, right, well done, beautiful, right? So we look at the center of the earth, we look at the angle that's being created between the 2 points, and maybe a more helpful drawing would be to actually draw that sector. So I've got Beijing,
Is that meant to be?
and I've got Perth. I want to find this angle here, okay? And we also have to be careful, because remember, we've got that equator straight through the middle. Okay, that's
Wait, where do you start that? I'm so confused.
Yeah, which bit, Tamika?
Where are we getting that angle from?
So let's come back. So we're trying to find the angular distance. And if we look back on our original globe, this is AOB. The angular distance is the angle between the 2 points from the center of the earth, right?
Yeah.
Can you see that?
Yeah.
Cool. And we come back to this question. So we come back to this question. And I see, okay, I've got Beijing and Perth. I want to find the angular distance.
Can you
So
draw
it's
the
the angle that's
sector
being
on
created.
that?
Sorry?
Can you draw that sector or whatever it is on that one?
Yeah, I think
It's a bit trickier because then I'd have to do maybe like this.
Yeah, but
Yeah, do
then it's
Okay,
better.
sure.
Does it matter what way you point?
Not really, no, it's fine.
Anyway.
Okay, so then you've got, is this a bit more helpful?
Yeah.
Okay, cool. So then I've got 40 degrees here, because I'm going from 40 degrees north to 0 degrees, which is the equator, and what do I have on the bottom? I've got 32 degrees, perfect. So, I want to find the angular distance, I have to put those together. That would be 40 degrees plus 32 degrees, and as Joe said, 72 degrees is my angular distance. That was for me.
How to calculate the shortest distance between Beijing and Perth to the nearest kilometre, given that the Earth's radius is 6,000?
Okay, so this is something they've given it to us, and I just like to write down as good practice all the information I know. So I know r is 6,400, and I know theta, well I just found the angular distance between the 2 points, that was 72 degrees. Okay, let's put that together, let's find the shortest distance. The shortest distance is going to be that arc length there. Okay, I'm just going straight from Beijing to Perth, so I'm going to say L equals to theta over 360.
Is the R equals 64
Yeah, 100.
part of C?
Honestly, yes. That's just me writing down the information, because I said I really like to write down the information, so I know what I'm working with. 80477, and remember, round to the nearest 477.
8042 kilometers, yeah.
Yeah, so we're rounding to the nearest kilometer, so in this case, 0.477, sorry.
Yeah.
So then we'd be rounding down. Okay. Okay, let's look at one more example. So the first thing is, hopefully we're familiar with this, what great circle passes through C and D. So we know it has to be either some longitude or the equator. And you look at the diagram and it's pretty clear, well, C and D, they both pass through the equator, which is 0 degrees. Okay, so let's put that in. So 3A is the equator. B. What is the angular distance between C and D? Again, hopefully we're really comfortable with this idea. Just one thing that might not be so obvious, the angular distance in this case, well, I want to find this angle here. And again, I want to look at my great circles. So I know I've got 50 degrees west and 15 degrees east. So what's going to be in the middle between them?
Would that be?
Let's think.
That's the prime meridian.
Perfect. It's the prime meridian that cuts straight through.
It says they were heard.
Yeah. No, I
Okay.
knew
Keep
that.
going.
So this angle here, I know because I'm crossing between the eastern and western hemispheres. This is going to be 50 degrees.
No, we did that last lesson.
Oh, do you?
And this angle, what would this angle be here?
15 degrees.
15 degrees, okay? So make sure you realize that you're actually crossing between the hemispheres. Don't just take the difference. Don't just think, oh, okay, 15, 15, let's just subtract them. Just look at the question carefully and see, okay, am I crossing a hemisphere? I am, so I have to remember there's actually the prime meridian, the 0 degrees longitude in the middle there that I have to account for. So now you know your angular distance, you know theta is going to be 50 plus 15, which is just 65 degrees, okay? And then you know R is always going to be the same, it's 6400. Can you put in for me now what your, oh sorry, that's, the question B, so it's just the angular distance. So,
Is this going to be in our trial?
Probably, yeah.
Is that
Wouldn't it be minus? I think it would be minus, not plus.
So remember the angular distance, I just rubbed it off on my one, but the angular distance is the angle between C and D.
So
Okay.
that's all we're going to find out.
Yeah, so I'm just trying to find the angle here. What's the angle between them, okay? And I want to make sure I've got the whole angle. And I know that the prime meridian cuts through the middle, which is 0 degrees. So I know I've got 50 degrees on the left, because from 0 to 50 degrees west, that's going to be an angle of 50 degrees. What is it going to be from 0 to 15 degrees east? Well, that angle size is also 15 degrees. So if I want the whole angle, I have to put them together. And how do I put them together? Well, that's going to be addition, right? So 50 plus 15, that gives me 65. Does that make sense?
So now we have to find the L, the length.
Good, yeah. And what information do we know? Well, I know theta is 65. And can you tell me R again?
Oh, isn't it 6,400?
Perfect, yeah. Okay, so all we have to do is substitute that into our formula. Jordan, did that make sense? Why you need to add, not subtract? Whew. So you should get 7, 2, 6, 5, 6. Okay, and again, we're going to do the nearest kilometre, so we're going up in this case. 7261.6. 721. Cool. Next one, Chloe. What great circle passes through A and D? Which is it going to be this time? What great circle are we looking at?
50 west.
Yeah, 50 degrees west. So remember, it's going to be the longitude. They don't both pass through the equator, so it's going to be 50 degrees west. Again, this is another great circle distance question. So that's just talking about the distance from A to D. So again, we just substitute those values.
A and D.
Yeah, okay. So that, you see that's going to be 48 degrees.
Why is it
Because
48
it's 0 degrees on the equator, but then what's happening at the top? Well, A is at 48 degrees north, so that's going to be an angle of 48 degrees, right? Remember, think back to your longitudes and latitudes.
Okay.
Yeah, does that make sense?
Yeah.
Because your latitude is starting from the equator and it's going all the way up to the top. So if it's 48 degrees north, we're creating an angle of 48 degrees. Okay?
Okay,
Yep.
okay, yeah.
Cool.
I'm just very confused.
That's alright. So theta in this case, 48 degrees. Okay, let me just do F really quickly. Actually, did you guys get E? Any questions about
Yeah,
this
no,
one?
that's fine.
Yeah, cool. So F, like you might be thinking, oh, I have to do this question again. Are you serious? Well, if you actually look at it, if you look at F, right, what's it asking for this time, Joe?
Literally the same thing.
Yeah, exactly. It's asking for B to C, but you realise, well, B is on the same latitude as A, and C is also on the equator.
362 kilometers.
Exactly. So you don't actually have to do the question again. You can just realise, oh, it's going to be the same answer. F is just also going to be 5,362 kilometers. Okay? That's all you have to do.
That's it.
Yeah.
Alright.